Now first we draw our XY line, then we mark the X and Y point, and we know above XY line in first angle there is a HP plane, VP plane, and below XY line there is a HP plane. Now and 25 mm in front of VP. So what we do? We mark our point P and P dash. So 40 mm below HP, I move the 40 mm downward direction. It is my point P dash. Condition with HP, always there is a elevation point. You can mark the 40 mm. 40 mm. All dimensions are in mm. So we mark the 40 mm here, and 25 mm in front of VP. So again 25 mm in front point always below XY line. So we move the 25 mm and we mark the 1 point. It is our plan point P. Condition with VP. So always it is plan point, and you remember point P, it is given in below HP and in front of VP. It means it is given in fourth quadrant. So we know in fourth quadrant our both the point plan and elevation both are below XY line. So this 40 mm dimension line, and this is our dimension line for 25. After that, you can draw the locus, the line parallel to XY line. So for that we arrange our scale parallel to XY, and from P dash we draw the locus of P dash. Similarly, you can draw the line parallel from P point then you can write the name of these two locus. So here we write the locus of plan point P and locus of elevation P dash. What you understand here, whichever point you can get on particular locus. If you get any point on locus of P dash, it is the elevation points. On locus of P, the points should be always plan points. Now the end projector distance, it is given 130 mm, and we know the end projector distance, it is the horizontal distance between final points. So I mark the 130 mm end projector points, and from this point we draw the one more two locus. So your point Q, it is given 75 mm, 75 mm above HP. So our point above HP, that means projection, it is above XY line. Condition with HP, always there is a elevation point Q dash. So I mark the Q dash here. Then 30 mm behind VP. So the point behind VP, it means the projection, it is above XY line. So I move the 30 mm. Then plan point Q, because it is a condition 30 mm behind VP, it means the condition with plan points. So it is a Q points. Now again we have to draw the line. There is a two locus of the other end. So first I draw the locus from Q point. It is called as a locus of Q, and one more locus parallel to XY line from Q dash, it is called as a locus of Q dash. So you have to write your simple locus of Q plan point. And similarly you can show your locus of Q dash. Q dash, it is our elevation locus. The same rules here. Whichever point you get on locus of Q dash, all are the elevation points. Now understand, here on particular this horizontal line, we have the 2 points. One, it is Q dash, it is already there, actual elevation endpoints, and one more point, that is a endpoint of true length, that we call as a Q1 dash. Similarly here, point of true length, that we call as a Q1 dash. Similarly here, on this locus there is a one Q points, it is a plan point, and second it is a end point of true length in a top view where your line inclined to VP, it is Q2. Now how to get? Now first we joined our P dash and Q dash, and it is called as a actual front view. So simply I am writing this front view, and this actual front view, it is inclined to XY line. This angle we call as a alpha, the front view inclined to XY line. Now first we go to the line inclined to VP. So for that, what we do here, now here first we take the radius P dash Q dash, center P dash, and we make our front view parallel to XY line. So I am going to rotate my front view, and simply I am give the direction of moments. Simply we show the direction of moments. Now it is here you can get your Q2 dash point, elevation point Q2 dash, and this line P dash Q dash, it is our front view length, and we know the front view length P dash Q2 dash parallel to XY line, its top view PQ2, it is line inclined to VP. So for that what we do, we draw the perpendicular line from our Q2 up to plan locus, because we are going to find out our plan point, the line inclined to VP. So here I am extending, do the vertical projection on locus of Q from Q2 dash, where you can get your Q2 points, that is a plan point Q2. Now join your P and both plan points, the one and P and Q2. And it is called as a line inclined to VP. This is our answer, that is called as a top view plus true length. My line PQ, it is inclined to VP. So here you can get your angle phi. This is called as angle phi, your line inclined to VP. So first measure the question, here the question it is measure the true length. So first we measure the true length. So this is a PQ2, that is 182 mm. So here I am writing my answer. The first answer, the true length 182 mm. Then the next answer here you can get the line inclined to VP, and simply we measure the angle of the PQ2 with XY line, and it is show the 17.5 degree. So here I am writing the line inclined to VP 17.5 degree. That is angle phi. Here it is your angle phi. After that, same method we apply for our plan, actual plan. Now I join the plan point P and Q. So for P and Q, first I join this P and Q, and it is your actual top view. Simply you can write here actual top view, and the line AB inclined to XY line, that angle we call as a beta. So similarly you have the PQ line here. So this PQ, it is inclined to XY line, this angle we call as a beta. Actual top view inclined to XY line. Now what we do here, we take the radius P2Q, and I make my top view parallel to XY line. So I rotate it up to locus of plan point P, and here I got my plan point Q1. So now you can write this PQ1, it is your top view length. Top view length. The PQ1, it is my top view length, which is from Q1. So we move the vertically on locus of Q dash. So here you can get your Q1 dash point, elevation of Q1 points on locus of Q1 dash. So now you can join this Q1 dash with your P dash point. So I join the P dash, Q1 dash with a straight line, and it is my actual elevation, front view plus true length. So I am writing simple here, this front view plus true length, and your black line is your front view plus true length, and it is horizontal, makes the angle, this angle we call as a theta, line inclined to HP. So now measure your angle here. So I use the protractor and we measure the angle, black line angle with XY. It is 37.8 degree. So here we can write line inclined to HP 37.8 degree. Now you can do the cross check. How to do the cross check, measure the length of P, measure your length P dash Q1 dash, and it is 82 mm. So in top view you have the answer, the true length of the line PQ, it is 182 mm. In elevation it is also 182 mm. So again I am going to repeating here fastly. The first you mark your given point P. From this point you can take the end projector distance 130 mm. Then you can mark your projection of point Q. First you join your PQ, that is actual top view inclined to XY line, that is angle beta. Now make the parallel. You can get the Q1, that is your plan point, and its elevation always on locus of Q dash. So we move the vertically projection, then we can get the Q1 dash. Now I join this Q1 dash with elevation point P dash. We can get our line inclined to HP, and the answer it is 37.8 degree. Similarly, you can capture your P dash Q dash actual front view. First make the parallel. Then when you create this parallel, it is your front view length, that is a Q2 dash. So its plan point Q2 on locus of Q. So for that we move the vertically and we mark the Q2. Now I join this Q2 point because I know this is the end point of true length of PQ line. So I join with plan point P, and I join PQ2. I measure this length, it is 182 mm, and it's inclined to XY line, that is angle phi, line inclined to VP, 17.5 degree. Thank you for attending the online class. Welcome to my next class. Subscribe this channel. You can get the